Hey guys, welcome to question MM344 of the Maths Methods Fortify study guide. So, in this question we've got the golden-faced butterfly lives only in a small section of the Amazon rainforest. Its population is being monitored for documentation purposes. The observing scientists recognize that the rate of increase of the butterfly population can be modeled by the function dp on dt equals t sine of t on 2 plus 20, where t is greater than 0, and where p represents the total population of butterflies in thousands, t months after observation starts. Awesome. And part A, I ask us to evaluate d of dt or dt cos of t on 2. Awesome. Now, we have our calculator, which means we could do this in Kaz, but that's not going to get us full marks because it is a 2-mark question. So what we need to do is actually do this by hand. So what we're going to do is let y equal t cos of t on 2, and then we're going to say y is equal to, because what we've got in the middle here is a multiplication symbol. So the way we're going to differentiate this is by using our product rule, right? So we've got one function times another function. So we're going to say u times v, where u equals t and v equals cos of t on 2. Awesome. And then what we're going to say is that our derivative is equal to u times dv dx plus v times du dx. That's our regular product rule. And then from here we can say that our u is t, so t times the derivative of cos t on 2, which is negative 1 on 2 sine t on 2, plus v, which is cos t on 2, multiplied by du dx, which is, du dt, my bad. That should be dy dt. Du dt, awesome. The derivative of that is 1, right? So times 1. So then we end up with cos of t on 2 minus t on 2 sine of t on 2. Awesome. And that's our derivative. Sweet. So our first mark comes when we recognize that we need to use the product rule, so somewhere down here. And then our second mark comes when we actually find the derivative. Guys, that's it for part AI. Let's move on to part AII. Part AII is a 3-mark question and says, hence, find the number of butterflies present in the population 12 months after observation starts, correct the nearest butterfly. Awesome. So, how are we going to do that? Well, we need to find P of T, right? We're not going to be able to find the number of butterflies present if we don't know what the function for P of T is, right? So in order to do that, we're going to need to anti-derive our dp dt, okay? So because it says hence, we're going to need to use the previous question in our answer, which is the derivative of t cos t on 2. So previously we found that the derivative of t cos of t on 2 was equal to cos of t on 2 minus t on 2 sine of t on 2, which means that we're going to need to use this in our answer now, okay? So what we're looking for is, we are looking for the derivative, or sorry, the integral of t sine of t on 2, right? Which is almost this kind of thing. Now we can do this in our Kaz, and you know, I think that would be good to do just to confirm everything, but we need to do this by hand to show that we know what's going on and to get all the marks, okay? So first things first is integration by recognition is what we're going to be using today. So because the derivative of this is this, the antiderivative of this is this, which means that the antiderivative of cos t on 2 minus t on 2 sine t on 2 dt equals t cos of t on 2. Awesome. Now, from here, we can, well, we want to get this by itself, the t sine t on 2, right? Because that's the function that we're looking for. So what we're actually going to do is separate these out. So we get the integral of cos t on 2 dt minus the integral of t on 2 sine t on 2 dt equals t cos of t on 2. Cool. And then from there we can actually evaluate this. Actually, you know what, we're going to separate these out and get this by itself. So we're going to get this on one side by itself. So what we end up with is integral of t on 2 sine t on 2 dt equals integral of cos t on 2 dt minus t cos of t on 2. Awesome. Then from here, we are going to evaluate this. So we get integral of cos t on 2 is 2 sine t on 2 minus t cos of t on 2. Awesome. And that's equal to our integral of t on 2 sine t on 2 dt. Sweet. But we don't want t on 2 sine t on 2. We want t sine of t on 2. So what we're going to do is take out half as a common factor. We're going to get half t sine of t on 2 dt equals 2 sine of t on 2 minus t cos of t on 2. I know this is a lot of work, but it's just part of it. So we're going to multiply both sides by 2 to get rid of this 1/2. So we get t sine of t on 2 dt equals 4 sine t on 2 minus 2t cos of t on 2. Awesome. I'm going to go back up here. Sweet. But we want t sine of t on 2 plus 20, right? We don't want just this, we want the plus 20 on the end as well. So what we're going to do is we're going to say that integral of t sine t on 2 plus 20 dt is equal to this. So 4 sine of t on 2 minus 2t cos t on 2 plus the integral of 20 dt, right? Because what we've done here is we've added the integral of plus 20. So we have to do that to this side as well. So we get plus the integral of 20 on that side, which means we get 4 sine t on 2 minus 2t cos of t on 2 plus 20t, right? Because the integral of 20 is t. This is our integral, okay? So if you did this in your calculator, you would have got this. This is our first mark. So I know this is a lot of work. Oh, you know what? This is actually probably your first mark down here. And then integrating this is our second mark. So Let's just get rid of that. So what we end up with is the fact that P of t, which is this, is equal to that. So P of t is 4 sine of t on 2 take 2t cos of t on 2 plus 20t plus c. Awesome. Now, the question tells us that the population is 0 to begin with, and that the scientists have kind of introduced it. So P of t equals 0 when t equals 0. So 0 equals 4 sine of 0 on 2 minus 2, 0 cos of 0 on 2 plus 20 times 0 plus c. All of this is equal to 0, so therefore c equals 0. So P of t is equal to 4 sine t on 2 minus 2t cos t on 2 plus 20t. This is our second mark here. So we've got our P of t. And now we want to find the population after 12 months. So we can simply sub in 12 for our t value. So P of 12 is equal to 4 sine of 12 over 2 minus 2 times 12 cos 12 on 2 plus 20 times 12. And this is equal to 215.838. And because this is in thousands, our population is actually this times 1,000, which is 215,838 butterflies. Now don't forget your butterflies on the end, because that's actually our unit in this case. That is our third and final mark for part AII. I know that was really long. If you have any questions, please let me know. But that's it for part AII. Let's move on to part B. Part B is simply a 1-mark question and says, how fast is the population growing 2 months after the observations begin? Give your answer correct to the nearest butterfly. Awesome. So what we're looking for is the growth rate 2 months after the observations begin. So we know that the growth rate is given by this formula here. So all we've got to do is simply sub in 2 for our t value. So we get 2 times sine of 2 over 2 plus 20, and what this gives us is 21.683, and because this is in thousands, it is growing at a rate of 21,683 butterflies per month. That's our first and only mark for part B. Let's move on to part C. Part C is a 2-mark question, and says the population starts decreasing for the first time between t equals a and t equals b. Find the values of a and b correct to 2 decimal places. Awesome. So guys, the easiest way to do this would probably be to actually sketch this on your Kaz and then show it that way. But what you would kind of do, actually I'm just going to get rid of this. But what you would kind of do is say that it starts decreasing when the gradient is less than 0. So it's decreasing when dp dt is less than 0. And you could say, according to Kaz, it starts decreasing between 21.29 and 23.03. So that would be your first mark. But we haven't actually stated what A and B are, right? So then we need to say that A is equal to 21.29 and B is equal to 23.03. And that's our second mark. So guys, sketch this on your Kaz, and you'll see where this is less than 0 between 21.29 and 23.03. If you have any questions, as always, just let me know. But that's it for part C. Let's move on to part D. Don't include this, please. So part D introduces a new concept and says the shape of the wing of a golden-faced butterfly can be modeled by the functions f of x equals x take 2 between 0 and 5, and g of x equals negative x take 5 on 2 squared plus 85 on 4 between 0 and 5, as shown on these axes below. All dimensions are given in millimeters. Sweet. So the other wing can be modeled by the functions y equals f of x plus k and y equals g of x plus m, where k and m are positive real constants. Now, part D says if f of x plus k equals f of negative x and g of x plus m equals g of negative x, find the values of k and m. Sweet. So what I would do in this situation is to say, I would define, so what you would actually write in the Kaz is x minus 2, and then you would click control var, which gives you that store arrow, f of x, okay? And then just click enter, and it should say done when you do that. Then I would say negative x take 5 on 2 squared plus 85 on 4, control var, which gives you the store arrow, g of x, and then click enter, and it should say done. And then what I would do is say solve, so menu 3.1, solve, f of x plus k equals f of negative x for k. Enter. Now this should give you a value of k equals negative 2x or k equals 2. Now because k is a positive real constant, k must equal 2. So that's your first mark. I would do exactly the same thing here. So then I would say solve g of x plus m equals g of negative x for m, and then that would give you m equals negative 2x or m equals 5. Since m is a positive real constant again, m equals 5. That's your second mark. So guys, the important thing to note here is that you have your calculator at your disposal, so you really need to try and use it as much as possible, obviously within the bounds of showing your working and everything like that. So I would actually write all of this as my working, just to show that you kind of understand what's happening. If you have any questions about it, just let me know. I know it's a little bit confusing, but just chuck them in the comments below and I'll answer them as soon as possible. So guys, that's it for part D. Let's move straight on to part E. Part EII is simply a 1-mark question and is pretty straightforward. This is designed to be kind of a bit of a simpler question. 1 mark. And it says, find the maximum wingspan of a golden-faced butterfly correct to the nearest millimeter. Awesome. So the question tells us that the domain of f of x, so this bit here, is from 0 to 5, right? So from here to here is 5. Which means that the maximum wingspan is actually going to be from here to here. Now, if this is symmetrical about the axis, which it is, because this is the same as g of negative x, this is 5 and this is 5, which means that the maximum wingspan is going to be 10 millimeters. It's a very small butterfly. And that's your first and final mark for part EI. Let's move on to part EII. Part EII is a 2-mark question. We're going to have to find out some area here. So it says, find the total surface area of a butterfly's wings, one side of a butterfly's wings, given by the shaded area in the diagram above. So all of this area here. Give your answer correct to 2 decimal places. Awesome. So first things first is the easiest thing to kind of recognize here is that both of these areas are the same because it's symmetrical about the axis. So all we're going to do is actually just find one of them, and then we're going to just times that by 2, and that's going to give us the total area. Now, just keep in mind that this is just one side of the their wings, not the front and the back, just the front. So surface area is equal to 2 multiplied by this area, which is the area between 0 and 5, right? Because this is 5 and that's 0, of g of x minus f of x. Right, because whenever we want to find the area between 2 functions, we do one minus the other. So 2 times 0 to 5 of g of x, which is negative, x take 5 on 2 squared plus 85 on 4, minus x outside of x take 2, dx. Now, expanding all this out and grouping like terms, we get from 0 to 5 of negative 2x squared plus 7x plus 15, dx. Actually, this was our first markup here, and that gives us a total surface area of 158.33 millimeters squared, which is our second and final mark for this question. That's our final answer. And that actually wraps up MM344, guys. If you have any questions about this, please hit me up in the comments below. But otherwise, as always, thank you for watching, and I'll see you in the next video.